So we always start by factoring, and the top here can factor to x minus 1, x minus 4, and the bottom is 1 minus x. Now, I'm going to write 1 minus x just temporarily here. I don't want you to write anything there right now. But I want you to notice that whenever you have a binomial, an x minus 1 and a 1 minus x, what can we do with that? I think we've seen this often enough now that instead of writing 1 minus x on the bottom, I can factor out a negative, and then it becomes x minus 1. Why is that important? Well, now these factors are identical, so they'll simplify. So in step 1 is always about our vertical asymptotes and holes. Our non-permissible values, x can't equal 1, and in this case, it's a hole. It's a hole at 1 comma something. How do we find out what that 1 comma something is? Well, we take our simplified formula and deal with that. Now, I want to look at the simplified formula because it's simplified and almost left nothing on the bottom, or a 1 on the bottom, but there's still that negative. So we have this right now. And I want to rewrite this and ask you if you're comfortable with that. How do we go from x minus 4 all over negative 1 to negative x plus 4? Okay? So one way, when you're dividing by negative 1, both the x and the negative 4 are being divided by a negative 1. That would make the x negative and the negative 4 positive. You could also get rid of that negative 1 on the bottom by multiplying the top and bottom by negative 1. Because that would make it positive 1 on the bottom. And you'd have to distribute the negative 1 on top. But we do need to write it in this form so that we can graph it. Because then if it's in that form, we can graph it. We know how to graph an equation of a line. We also can now figure out where our hole is going to be. How do I know that the coordinates of my hole are at 1, 3? Well, once you've simplified it, you can plug in that non-permissible value into your equation. And whatever that would be, which is 1, 3, is the equation of your hole. Or not equation, but the coordinates of your hole. So we can draw our hole at 1, 3. If I'm graphing this equation, it has a y-intercept at 4, 0, 4. There's my y-intercept. And I could graph my line. If I wanted to label my x-intercept, I could solve for that as well. At 4, 0. And that's all we have to do in this situation because we simplified it into an equation we already knew how to graph. And whenever you have a hole, you always graph the equation you get after you've simplified it and just add the hole to that simplified equation. So we're no longer having to worry about this because this form makes us think there should be an oblique asymptote because we have the higher degree on the top. But we don't worry about oblique asymptotes until after we've figured out if it has holes, and if it does have a hole, we graph the simplified equation, and the simplified equation is just a line, no oblique asymptotes. Okay, questions for practice on this one are 3, but I'm going to give you a couple of more examples to deal with first.